Okay, right now I hope you have the answer on your paper already, and let's do the example together. So we see in the algorithm, we will calculate the closure of some attributes iteratively until we have no changes for the x. So by following this algorithm, we do it by step. So before we go to the loop, we start with x equals to what? Let's do a closure of AB first, right? So we have a closure, we have AB, we have x equals to AB in the very beginning. Let's go to loop 1. Inside loop 1, we will repeat until x doesn't change, and we check all the FDs in the S set, and also check if the B1 to Bn is in the X or not, and also check whether C is in the X or not. If B1 to Bn is in the X and C is not, then we can add a C to the X set, right? So in loop 1, we check the first FD, we have AB implies C, right? We check the first FD, it is AB implies C, right? So according to our X, we find AB is in the X set, C is not, right? Therefore, this if clause is true, right? And we have to add a C to the X set. And get x equals to what? X will be equal to ABC, right? So this is within the first loop, loop 1 and FD1, right? And the next one, we need to check the second FD, right? We are still in the loop. FD2, we have checked this AB implies C already. Then we go to the next FD, we check the second FD, we check AD implies E, right? AD is not in X, and E is not. Since AD is not in X, we will not add this E into our X anymore, right? Because this if clause is false. We do nothing. Right. Then we can go to the third FD. Still in the first loop. FD3, right? We check B implies D. B is in X and C and D is not. We will add D to X, right? And get X equals to what? X equals to A, B, C, D, right? This third FD we can get. Then we check the last FD. Stay within the first loop. Right. We check AF implies B. AF is not in X and B is in X, right? We do nothing. So this is the first loop we can do, right? We check all the FDs and also check if this if the head and the tail of the clause is the attributes is in the X or not. If so, if this B1 to Bn is in the X and the tail is not in the X, then we can add this tail as new attributes to X, right? We check all the FDs, and the X we can get right now is X equals to ABCD, right? Since X changes in this loop, X changes. Loop 1, right? We will go to another loop. We will start another loop 2, right? And then we can start loop 2. We also check all the FDs. Let me copy this here. So change this one to 2, right? So we still check the FD1 first. We check AB implies C. We know in the X we can get it right now. The X we can get is A, B, C, D, right? We check AB is in the X, C is also in the X, right? And here in loop 2 for the first FD we do nothing, right? You can follow me, right? In loop 2, the X we can get right now is A, B, C, D. Then we can start checking all the FDs. A, B implies C. Based on the current X, we can get A, B is in X, C is also in X, right? This if clause is false, therefore we do nothing for the loop 2 FD1, right? And then we can go to FD2, AD implies C. We find AD right now is in X right now, right? And it is not. Then what do we do? We will add in into X. And get equals X equals to what? A, B, C, D, E. And when we go to loop 2 FD3, we check B implies D, right? We see B is in X, D is also in X, right? Then we do nothing for this loop, right? Then we go to loop 2 FD4, we check AF implies B. AF is not in X, right? X contains A, B, C, D, E. AF is not, B is in X, we do nothing, right? Then next, what? Shall we stop here, right now? Because X changes in this loop, right? So we need to start loop 3 again. Right? And inside loop 3, what we will do is to check all the FDs again. What we get is very similar. We can copy this one instead. The X we have right now is not different, is A, B, C, D, E, right? So we have the loop 3, let me use a small font. So change this one to loop 3. And we check all the FDs. We check A, B implies C, A is in X, C is also in X, we do nothing. We check AD implies E. Right now, X equals to A, B, C, D, E. AD is in X, E is also in X, right? So we do nothing here. And then we do checking that B implies D, right? B is in X, D is also in X, we do nothing. And we check AF implies B. AF is not in X, B is in X, we do nothing. So because in this loop, this X doesn't change, right? We will stop. Let me write down here. X doesn't change, right? We'll stop. And return X closure equals to what? X closure equals to A, B, C, D, E, right? So this is a process we calculate the closure of some attributes. So we do this iteratively way, right? Iteratively until this X doesn't change. So remember, if X changes in the previous loop, we need to start another loop until this X doesn't change, right? Even though we know in the loop 3 we will do nothing actually, but we still need to do the loop 3 according to the algorithm, right? So based on this question, we can get the closure of A, B equals to what? Equals to A, B, C, D, E, right? And this is the process we can get this closure for A, B. In a similar way, we can also calculate the closure of F, and we can do this together, right? Let me delete this one. And for the closure of AF, we can do it in a much faster way, right? Because this process is to provide you with some ideas how to calculate the closure. And if you are doing your homework, you can do this in a much faster way on your papers. We start X with what? With AF, right? And we check all the FDs. AB implies C, we can do nothing, right? AD implies E, we do nothing. B implies D, we do nothing. AF implies B, we will need to add this B into the X, right? Here we don't show the process, we just show you the answer, how to calculate the closure directly. But the process is very similar. You need to have the process which provided before in your mind. So the process is the same as what we write down before, but we don't want to show the process again. It takes too much time, and we just show you the answer to how to calculate it. And we also need to follow the same process. Okay, so this is the first loop, and based on the current X, we need to start another loop again, right? And we start loop 2, checking all the FDs. AB implies C, we have AB here, C is not, we have to add a C here, right? And then we check the AD implies E, we don't have D, right? Let's skip it. We have B implies D, we have B here, right? Therefore, we have added D into the closure. And then we can check the F. F we have used already, we don't do anything here. So this is the second loop. And then we start loop 3, we check again, AB implies C, we have C already, right? AD implies E, we have AD, we don't have E, therefore we have to add an E here, right? B implies D, F implies B. We have BD already, right? We don't do anything here anymore. And this is the second loop, and we need to start another loop again because this X changes. We go over again, AB implies C, AD implies E, B implies D, F implies B. Since we have the B, C, D, E already, we don't do anything in this loop. And we will stop and return the result at the closure for the AF, right? Therefore, we have a closure for F equals to what? We can reorganize these attributes into A, B, C, D, E, F, right? Okay, so this is a way to calculate the closure of AB as well as AF. You can compare with your answer. Let me remind you the closure of AB equals to what? The closure of AB equals to A, B, C, D, E. We have a closure of AB equals to A, B, C, D, E, and the closure of F equals to A, B, C, D, E, F. You can check with your answer on your paper to see if you are correct or not. And if you are not correct, you can also go over the process I showed you before and to check why or which part you make a mistake. Okay, so that's it for this example.